Hello guys, this is Niranjan K. I'm studying history Venkateshwara College of Engineering. So today I am here for explaining the topic of principles of inclusion and exclusion in the subject named discrete mathematical structures. So let's move on to the topic. Principles of inclusion and exclusion. Let's see the introduction. Inclusion and exclusion principles in mathematics are fundamental concepts that help to solve the counting problems. These principles allows us to efficiently calculate the number of elements in various sets. Understanding these principles is crucial in combinatorics and probability. The principle of inclusion and exclusion. The principle of inclusion and exclusion is a counting technique used to determine the size of the union multiple sets. It helps to avoid the overcounting when calculating the total number of elements in a collection of sets. The principle states that to find the total number of elements in union of sets, we must consider the individual sets, then subtract the intersections if any. So the formula of inclusion and exclusion. The inclusion and exclusion formula is expressed as modulus of A union B union C is equals to modulus of A plus modulus of B plus modulus of C minus A intersection B and minus modulus of A intersection C modulus intersection of B in modulus of B intersection C plus modulus of A intersection B intersection C. This formula can be extended to any number of sets. The principle is based on the idea of adding the sizes of individual sets and subtracting the sizes of intersections and adding back the sizes of intersections of multiple sets. So we see an example of two sets. Let A is equals to set of 1 and 1, 2, 3 and B is equals to set of 3, 4, 5. So we have to find the A union of B. So the formula goes like this. Modulus of A union B is equals to modulus of A plus modulus of B minus modulus of A intersection B. So the modulus of A value is 3 plus modulus of B value is 3 and modulus of minus A intersection B is 1. So we finally get the answer as 5. So, and we conclude that the union of sets A, B contains the elements of 1, 2, 3, 4, 5. So, we see another example of three sets. So, let A be the set of elements containing 1 to 3, and B be the set of elements containing 3, 4, 5, and C be the set of 5, 6, and 7. So, we have to find modulus of A union B union C. So we finally get the answer as 7 and the union of sets A, B, C contains the elements of set of 1, 2, 3, 4, 5, 6 and 7. So as you can see another example which contains intersection of common of two sets. So principle of inclusion and exclusion applications. The principle of inclusion exclusion is widely used in various mathematical problems, including counting arrangements, permutations, and combination. It helps in determining the probability of events occurring simultaneously or independently. The principle provides a systematic approach to handle complex counting situations efficiently. So, exclusion principle. The exclusion principle is another fundamental concept in mathematics used to count the elements that do not belong to specific sets. It complements the inclusion exclusion principle by focusing on the elements outside the union of sets, that is, in universal set. The exclusion principle helps in finding the number of elements in complement of set or sets. So the formula goes like this. Exclusion principle formula is expressed as modulus of A dash intersection B dash is equals to modulus of universal set minus modulus of A union B, where A dash and B dash represent the complements of set A and B respectively, and U is universal set as I told earlier. This formula allows us to calculate the number of elements that are not in sets of A and B, that are excluded from the sets A and B. The exclusion principle is useful in probability calculation and determining the number of elements outside the specific sets. So here is an example where universal set contains the number of numbers from 1 to 10 and set A contains 2, 4, 6, 8 and set B contains 3, 6, 9. So we have to find the exclusion principle. So we get the answer as 4 by using the exclusion principle formula, as you can see. So the elements that are neither in set A nor in set B are 1, 5, 7 and 10. So what is the difference between inclusion exclusion principle and just exclusion principle? So the principle of inclusion and exclusion focuses on counting the elements in union of sets, considering intersections. But the exclusion principle, on the other hand, deals with counting the elements outside the specific sets, focusing on complements. Both principles play essential roles in combinatorics probability counting problems in mathematics. So the applications of probability. Inclusion and exclusion principles are crucial in calculating probabilities of events in probability theory. These principles help determine the likelihood of multiple events occurring simultaneously or independently. By applying these principles, mathematicians can analyze the complex scenarios and make informed decisions based on probabilities. So the real world applications of inclusion and exclusion principle, they have practical applications behind mathematics such as computer science, economics, and epidemiology. In computer science, these principles are used in algorithms, design, and analysis. In epidemiology, they help in understanding disease spread and population dynamics. So finally, the summary of this principle is that this is powerful tools for counting the elements in sets of calculating and probabilities. The principle helps in determining the total number of elements in union of sets. And also the exclusion principle complements is focusing on elements outside the specific sets. So the importance of these principles in mathematics. Understanding these principles is essential for solving complex counting problem efficiency. They provide systematic approach to handle situations involving multiple sets and overlapping elements. So the final conclusion is principles are foundational concepts in mathematics that facilitate counting and probability calculation. By mastering these principles, mathematician can tackle a wide range of mathematical problems with precision and accuracy. Continuous practice and applications of these principles strengthen problem-solving abilities and analytical thinking in mathematics. So that's all for today, guys. Thank you.